Hi, welcome back to the shop. This time I wanted to tell you a tale of three vices. We have a little hand vise I got from the flea market with a bent spindle and chewed up jaws. We have the newer brother of my benchvise, a nice piece with dovetail slide, but somebody broke the spindle on it, or in fact the spindle on these is fixed and the spindle nut is rotating and it twisted off, so we will also fix that one. And last in the row is this one with a 130mm width on the jaws. This is straight out of the scrap bin. It's rusted, but it's in good shape. The handle is not bent. It's not. Nobody did it hit with a hammer, nor is the anvil really banged up or the jaws chewed up. It's just dirty and rusty, so we will also clean up this one and paint it. So hang around and see what's next. Okay. First one is this nice little hand vise I got from the flea market for €1. I took it home because it has nice narrow jaws. The spindle there with the square thread is bent, but we can fix that. It's not too bad. Just get the spindle out. The spindle is in fact a button head bolt, and we will straighten out this bolt. And we're also going to remachine the jaws. We're going to mill them flat so they give a nice touch again. We can't take it apart farther because this joint down here is swaged together. You can't take these apart once they are put together, but we just need to clean it, clamp it on the milling machine and run a end mill through here to touch up the jaws. Okay, I don't really want to get off the old paint and the patina, I just want to clean off the dirt. So first we're using good old WD-40 just to soak it a bit, and brass brush always helps. Okay, here we have the wing nut and the bolt with the square thread. That's not a Acme thread, that is a flat thread. The crests of the thread are square. This is a pretty old school style of a thread, but in this case it's perfectly fine. These threads can bear quite a lot of load, and for the purpose of a clamping device that's fine. But as you can see, it got a slight bend to it, and we're going to fix this. I clamped the bolt between two pieces of plywood and I'm trying to straighten it out. And I'm going step by step. This is one of those operations you need 5 hands for. I got it straight enough, and we'll put it back into the handle.
kind of a glove. Let's right nut back on.
We are back in a usable, reasonable condition. What I'm also going to do while I recut the jaws is I'm going to angle them like this. I'm going to pull back the surfaces, and I'm going to do this because I want to grip I want them to grip in the front first. So when I clamp something with say 5 millimeters, I want it to be clamped in front, not back here like it's right now. Pencil for demonstration. When I insert the pencil in the handvice and clamp it, yeah, I drop it, and I don't know if you can see this, it actually clamps back here, and the part can wiggle in there. I want it that the front portion of the jaws clamps on stuff, so that's the reason why I'm going to back cut or relieve the back of the jaws, and we're going to do this on the milling machine. Ooh, yeah, they are pretty hard. Seems like they are hardened on the face here, but not. Oh, they are kind of hard here, but they are file hard right here. Okay, here's what we're going to do. I have this setup block, which is kind like a 1-2-3 block, but it has a step in it, it has a few threaded 6mm holes in it, and it's all ground. I made a pair of these a few years ago when I had access to a surface grinder, and this is what we're going to use. I have this short stud. I dropped the handvice on it and used a nut down here. And that's the way we're going to clamp this handvice down. Let's tighten this nut. And I'm just aligning by eye this with this surface so it's kinda like to each other. Okay, and just for safety we put another clamp back here. Oh, here you go, that's the setup I'm going to use. And now I can clamp this on an angle on the milling machine and the big vise and run an end mill along this. Okay, we're over at the milling machine and we have our setup. And now we're going to drop this into the vise. And I'm using a vise, a square, to sight down against this jaw, and set it to the desired undercut. And this is way too much of an undercut, so I'm tilting it down, and that's about how much undercut I want. And the setup block will stay in the milling machine for both sides. I will not touch this setup right until I'm done. I will just loosen these two clamps, rotate it around and clamp it again. Okay. I set up a 3-flute coated carbide end mill. It's not a new end mill because these jaws are hardened and the end mill will take a beating with that procedure, so I'm going to use a used one. You saw that went very well. I got a very nice surface finish, almost a mirror finish. Now I'm going to turn this handvice around and machine this. And second side. Okay, that went also very well, and I got a nice surface finish. Okay, I cleaned everything up. I rounded over the edges slightly on the bench grinder, and I'm happy with it. Now we put this €1 flea market find back to good use. At first I was a bit worried that these jaws might only be surface hardened or case hardened, but as you can hear, they are still hard, and seemed like the whole jaw in front is hardened through. Also on the outside the file doesn't catch. Yeah, and by relieving the back of the jaws, I can now very precisely grab small parts to hold them, like on the bench grinder. When you're grinding very small parts and don't want to burn your fingers, you can use something like this, or holding small sheet metal parts for drilling or soldering or welding or brazing or whatever you want. Every time you want a pair of fingers that are a bit more durable than your own, something like this is very handy. Here we are with the second vise with the twisted off spindle nut, and we're going to take it apart. First we take out the actual spindle, or should I say it's the spindle which holds the nut on front. So let's take this out. This plate goes off and you can pull out this spindle piece. There is a washer, I think that's hardened, and there is the spindle. And right here in front you can see that when they made this was actually welded on. This nut and this spindle, these are two pieces, and they welded it on. And for some reason when they cleaned up the weld, it looks like they cleaned up on a lathe and they undercut it, and that's the area where it broke. Okay, and for the start we're just going to clean up the broken weld here. And because I'm not sure what's in that weld, we're going to use a carbide tool. put a slight chamfer on the inside and outside. Okay, and for the spindle we need to set up the steady rest because this end is too big for my spindle bore. This lathe has only a 21mm spindle bore, and this knob has about 30mm. So and lock it in place. And ooh. Yeah, that's running very that's a bit wonky. Yeah. I'm going to draw this bit more out of the chuck so we can force it where we want it. If we bury this end very deep in the chuck jaws, we can't align the end here, and this is what we want. I set up a dial indicator to visualize how much runout I am at, and due to the big overhang I don't even need a hammer. I can just push that thing around, and it doesn't get better than 0.2 of a millimeter. I don't think that this pipe, this is a welded pipe, it has a seam, so it's not round. I'm just going to align the steady rest fingers and hope for the best. With the steady rest the runout gets kind of equalized, but you still have to set it up though it's straight. Otherwise you will get very funny geometrical errors in your part. That's fine. With that runout we can live. It's just a benchvise, not a high precision machine spindle thing. So we're going again for a carbide cutter. And the material of that pipe is pretty bad stuff to machine. I'm using one of my carbide boring bores. The pass with the boring bore was only to clean up the inside of the pipe. I didn't shoot for a particular diameter. I just want it to be cylindrical, smooth, and I wanted to get rid of the welding seam on the inside. Okay, I just turned down the end of the nut to fit the inside of the spindle pipe with a light press fit. Okay, we have the makeshift anvil out. That's a piece of railroad track, and we're going to press or hammer in the nut into the pipe. And that's a nice fit. That went right. And we have our nice V-groove all around, built by the two chamfers. That will give us our weld preparation. I set the pieces up in a V-block in the vise, and I put a second shop-made V-block on top, clamp everything with a Bessie clamp together. I didn't tighten this clamp down very hard, so I can still turn my part in the V, so I don't have to reclamp it while I'm going around. I got the spindle back into the vise body, and I dressed up the weld slightly with a file and some emery paper. And as you can see, it's not the ugliest weld in the world, so that's okay. And the best thing is, with that repair, the vise is back in working order. I just need to make 2 vise jaws, but I don't have material here for it right now. I'm going to use copper or mild steel. I would prefer copper, and I'm just going to cut into length, drill it, and counterbore it. Screw it on there. No need to show that on camera. You have seen that a few dozen times. So that's the second vise done, and now we can proceed on to the third one. Here we have a third vise. That's the scrap bin vise. That's a very common vise here in Germany. You see them almost in every fabrication shop. They can take quite a beating. They are forged, not cast. They have a BV spindle in them, and they are almost indestructible. And also you can see that this vise has quite of a lot of range. It can clamp, I think they can clamp up to 200 millimeters. Okay. There you can see this massive forged movable jaw with the double prismatic guideway, and also the very heavy Acme screw, feed screw. And also this is a 2-start thread. That means they can have a higher pitch, and this enables the vise to move very fast but still have a lot of strength in the screw. I got the spindle out. There is a hidden spring steel ring behind the washer, and you have to pry it out with a screwdriver. Then there is the washer that hides the spring ring, and a heavy duty, very heavy preload spring for the spindle to remove any slack in the spindle, and it's all very dirty. This vise has seen some use, and the grease has collected a lot of debris over the years. But look at the spring. This is a very heavy duty spring. The wire is about 3 millimeters in diameter here, and man, I can't really bend this, collapse the spring by hand. Then there is the spindle itself. Nice 2-start Acme thread and the bearing surface, and everything there looks still pretty good. The bearing surface has some wear to it, but it's not too bad. We will just clean it off and run and polish this area slightly. And then there is also a washer here, and that seems to be hardened to act as an axial bearing. I dropped all the parts into bins with hot water and citric acid to get rid of most of the rust. The citric acid will do a pretty good job on removing the surface rust and also the rust that's really embedded in the material. But on the handle you can already see that the rust is getting removed. If you recall a picture from before, it was all brown all over. It was very rusted and it's still pitted. The material is still gone, but it's getting cleaner. That stuff sitting in there for about 12 hours and the citric acid getting a nice yellowish color. Now we try to get that stuff out without making a huge mess. There is still a good amount of the original paint job left, and it's not looking too bad, so maybe I will just clean it up. Clean that apprentice mark in the anvil surface. It looks like somebody has burned a big hole with a stick welder in it, and clean that up and yeah, call it done. Got the whole mess off the bench, and this is what we're left. We have the big parts of the vise that are almost free from rust, and I'm still not sure about the paint job. Still think drop it back in. Doesn't look too bad. Yeah, it looks worn and used, but that's what it is. It's used, and I think I'm not going to paint it. It still looks okay. Now we're going to repair the anvil. I have my die grinder with a carbide burr, fine pitched carbide burr, and my safety glasses because these burrs throw a heck of a... The chips that come off there are just nasty, so we're going to machine this out so we have clean metal, and then we weld it. Now we're just going to weld it or fill it up with the TIG. The hole filled up pretty good, and in the next step we're going to machine the anvil surface flat, and the vise body set up on the shaper, and I'm ready to machine this anvil surface. First I tried to do it with the grinder, but it's just too much material to remove. And why bother if I can do a better job with a machine tool? I shimmed it with brass shim stock so it doesn't mar the scraped machine table. And you might have noticed I also put brass sheet metal under the distance pieces I put under my clamps. The only surfaces I let touch my machine table are machine surfaces or blank drawn surfaces from cold drawn material, but no rough surfaces, no castings, no mill scale will ever touch my machine table. So I always put something in between, and I have a roll of 1/10 millimeter brass shim stock that comes very handy for that jobs. I also had to tilt the top slide of the shaper so I can get in here and don't hit the fixed jaw of this vise. As I don't really know what the material of this anvil surface or the whole vise is, I'm using some cutting oil. Doesn't hurt. Is the tool bit, and the tip of it just was abraded away. I think I hit a hard spot in the anvil surface. I think it's in the area where I did my welding, and something created a hard spot, and yeah, I think we have to go to plan B and use a carbide shaper tool and see how that behaves. Set up a carbide tool and did cut a bit more material, and it works pretty good, but you can exactly see where the hard spot is, and it's in this area, in that light shine area. That's where I did my welding, and it seems that there is some carbon or too much carbon in the steel, and it hardened where I welded it. Surface cleaned up, and I don't want to take too much material off. I just want it to be flat again, and in the finish you can still see where the hard spot is, but that will clean up with some emery paper in the file. I will just clean up the surface slightly, and I'm very happy how it came out, even with the minor problems I had. Just going to clean it up with file and some emery paper or emery cloth, and I'm backing off the emery cloth with a file and with the surface with it. I got it back together, got some grease on the guiding surfaces and on the spindle, also in this axial bearing here in the movable jaw. Also, I replaced the missing bolt for the adjustment of the play. This bolt here just pinches together these two side pieces, and that's to adjust the play of the movable jaw. And as you see, there is not much play in it. Actually, that's moving back, but I don't think that's that it's more than 0.5 millimeter in both directions, just by wiggling it. And So we have the anvil resurfaced. We got all the rust off. We're leaving the paint shop. And yeah, that's it. I already have somebody who wants this vise, so I don't have to bother with eBay or something like that. It will go to good hands, so. And that was it. That was the tale of the 3 vices. So thank you for watching, and I hope you enjoyed.